a tangent meets a radius at a 90-degree angle. So if we had a circle and a radius of it, so if we knew the center and a point on the circumference, and we wanted to find the tangent at that point, we could find it using perpendicular lines. So we know that these two lines, the tangent and the radius, are perpendicular. They meet at a 90-degree angle. This question says the point P, 2, 5, lies on the circle. So 2, 5 is on the circumference, and the center is at -3, 7. Find the equation of the tangent to the circle at P. So we want to know the equation of the tangent. And to do that, we can find the gradient of the radius and then do the negative reciprocal, flip a minus, to find the gradient of the tangent. So let's find the gradient of the radius. So we just say x1, y1, x2, y2, and the gradient is the change in the y's, which would be 7 take away 5 over the change in the x's, -3 take away 2. So the gradient of the radius is 2 over -5, or -2/5. Then we can say, well, the gradient of the tangent is a negative reciprocal. So flip a minus, 5 over 2. And we know a point on that line, which is 2, 5. So we can just substitute it in to the gradient times x minus x1 equals y minus y1. So just substitute in x1, y1, and m, and that is the equation of the line. So that is the equation of the line. If we wanted to put it in a different form, either y equals mx plus c or ax plus by plus c equals 0, we can rearrange, but that is the equation of the line. I'm going to leave it as that. Here's one for you to try. Pause the video and give it a go. So the point 6, 3 lies on the circle. So you've got a point 6, 3 on the circle. The center's at -3, 6. And you want the equation of the tangent. So again, if you find the gradient of the radius, you know that you've got perpendicular lines, so you can find the gradient of the tangent. So for the radius, I have x1, y1, x2, y2, and the gradient is the change in the y's. So you've got 3 take away 6 over the change in the x's, 6 take away -3, so 6 plus 3. That's -3 over 9, or -1/3. So for the tangent, you want the negative reciprocal of -1/3. So that is 3. And you know you've got the point 6, 3 on the tangent. So you have to use the point 6, 3 because that's the one on the tangent. If you use the center, you'd actually be working out this line instead, which is not what we want. So just substitute in. So it's the gradient times x minus x1 equals y minus y1. So that's 3 times x minus 6 equals y minus 3. A circle has the equation x squared plus y squared plus 8x minus 4y minus 5 equals 0. verify that negative 1, 6 lies on the circle. So if this point is on the circle, x squared plus y squared plus 8x minus 4y minus 5 should be equal to 0. The left side should equal the right side. It makes the equation true, makes the left side equal the right side. So if we just substitute these in for x and y, so that would be negative 1 squared plus 6 squared plus 8 negative 1s minus 4 6s minus 5 equals 0. So you've got 1 and 36, which is 37. Take away 8, 29. Take away 24, 5. Take away 5, 0. So 0 equals 0. Therefore, negative 1, 6 lies on the circle. Find the equation of the tangent at negative 1, 6. So this time we've been given a point, but we don't know the center. We can work out the center using the equation. So we just need to put it into the right form. And to do that, we complete the square for the x's, complete the square for the y's, to get it into the form that we usually have for a circle, x minus a squared plus y minus b squared equals the radius squared, where AB is the center. So you've got x squared plus 8x. So half of 8 is 4, so it's x plus 4 squared. And we've got take away 16. So that's equivalent to x squared plus 8x. Y squared minus 4y. Half of negative 4 is negative 2. Take away 4. And then we've got minus 5 equals 0. So I don't need to find out the radius. It is 25, so the radius is 5, but I don't need to work it out. I just need to know the center. So the center is, what makes the x bracket 0? Negative 4. What makes the y bracket 0? 2. So the center is at negative 4, 2. So that's this point here. We can find the gradient now of the radius by doing the change in the y's over the change in x's. So the gradient is y2 minus y1, 6 minus 2 over x2 minus x1, minus 1 minus minus 4, so plus 4. So that's 4 over 3. So the gradient of the radius is 4 over 3. For the tangent, it's the negative reciprocal minus 3/4. And we know the point is negative 1, 6. So we've got x1, y1, and m. So the gradient times x minus x1 equals y minus y1, and substitute them in. So minus 3/4 times x minus minus 1, x plus 1 equals y minus 6. So that's the equation of the tangent. Again, if we were asked to put it in a different form, we would have to rearrange from there to get it in the form we're asked for. One for you to try. So pause the video and give it a go. A circle has the equation x squared plus y squared minus 6x plus 2y minus 27 equals 0. Verify that 2, 5 lies on the circle. So just substitute 2 in for x and 5 in for y, and we should get the left side equals the right side. So we've got 4 and 25, that's 29. Take away 12, which is 17, plus 10, 27. Take away 27, that's 0. So therefore, 2, 5 lies on the circle. Find the equation of the tangent at 2, 5. So again, we need to know the center first. So put it into the right form. That will be x minus 3 squared minus 9 plus y plus 1 squared minus 1 minus 27 equals 0. So the center is at 3, negative 1. And our other point is 2, 5. So let's find the gradient of the radius first. So x1, y1, x2, y2. The gradient is the change in the y's. 5 minus minus 1 over the change in the x's. 2 minus 3. So that's 6 over negative 1, negative 6. So the perpendicular gradient is a negative reciprocal, which would be 1/6. And then just substituting in. So we've got the gradient is 1/6. The point is 2, 5. So it's 1/6 times x minus x1, x minus 2, equals y minus y1, y minus 5. A circle has equation x minus 4 squared plus y plus 2 squared equals 125. A tangent to the circle has a gradient of negative 2. Find the two possible equations for the tangent. So we have a circle. We can work out the center. Well, the center is at, we can see the center is at 4, negative 2. We're at 4, negative 2 for the center. And we've got a tangent with a gradient of negative 2. So it's either here or here. And we know that a tangent and a radius meet at a 90-degree angle. So we can work out the gradient of the radius. It's a negative reciprocal of negative 2. So that is positive 1/2. And we can use the 4, negative 2 to find the equation of the radius. So the gradient times x minus x1, x minus 4, equals y minus y1, y minus minus 2, so y plus 2. And if I double both sides, x minus 4 equals 2y plus 4. Then add 4 to both sides, x equals 2y plus 8. So this is a version of the equation of the radius. I can work out where the radius intersects the circle. So if I solve these two simultaneous equations, I can find these 2 points. So we've got the equation of this line here. We can find out where it meets the circle by solving these simultaneous equations. So I can substitute 2y plus 8 in for x. So that will give me 2y plus 8 minus 4. So 2y plus 4 squared plus y plus 2 squared equals 125. Expand and simplify the brackets, make it equal to 0, and solve it. So if you want to write them out as double brackets, you can. I'm not going to. I'm just going to expand and simplify them without rewriting them. So I've got 4y squareds plus 8y plus 8y. So that's 16y in total. Plus 4 times 4, which is 16. Plus y plus 2 times y plus 2. That's y squared plus 2y plus 2y plus 4. And that's equal to 125 still. So I've got 5y squareds. I've got 20 y's. And I've got 20, take away 125. That's minus 105 equals 0. I can divide by 5, which means I can factorize it. So I've got y squared plus 4y minus 21 equals 0. So y plus 7 and y minus 3 equals 0. So y is negative 7 and y is 3. X is 2y's plus 8. So 2 negative 14s. No, 2 negative 7s is negative 14. Plus 8 is negative 6. 2 3s are 6 plus 8 is 14. So I've got the 2 points here now. So the 2 points where the radius meets the circle. So I know that these points are on the tangents. And the tangent's got a gradient of negative 2. So the equations, we've got a gradient of negative 2. And we've got the coordinates. So we just substitute them in. So just substituting them in, we've got the gradient times x minus x1. So let's do minus 6 equals y minus 7. Or we've got the gradient times x minus x1 equals y minus y1. So they're the two equations. They're all whole numbers, so they could be written in the form y equals mx plus c. But I'm going to leave them like that. Okay, one for you to try. Pause the video and give it a go. So we know the center of the circle is at negative 6, 3. And the tangent's got a gradient of 3. So the radius has got a gradient of the negative reciprocal minus a third. So we can write down the equation of the radius. So it's the gradient times x minus x1, x minus 6 equals y minus y1 times by 3 and expand the bracket. So minus x minus 6 equals 3y minus 9. I want x equals or y equals, so I can substitute it in easily. So I'm going to plus the x over to the other side. Or even, let's just add 6 to both sides. And then times 3 by negative 1. So x equals minus 3y plus 3. So now I can substitute that in. So I've got a circle. I know I've got a tangent two tangents, one here, one here. I found the equation of the radius. So I can find out 2 points on the tangents by finding where the radius meets the circle. So if I solve these two equations simultaneously, I can find these 2 points. So substituting in for x, negative 3y plus 3 So we've got negative 3y plus 3 plus 6 squared plus y minus 3 squared equals 90. 3 plus 6 is 9, so we've got negative 3y plus 9 squared plus y minus 3 squared equals 90. So we need to expand and simplify the brackets. So negative 3y times negative 3y will be positive 9y squared. Negative 3y times 9 is negative 27y. We've got another negative 27y and a plus 81. Then for the second bracket, we've got y squared minus 3y minus 3y plus 9, and it's equal to 90. So collecting the like terms, we've got 10y squareds. We've got minus 27 minus 27 minus 3, which is minus 60y's. And we've got 81 and 9, which is 90. Take away 90, so that equals 0. So let's just factorize this. Take 10y out, which leaves with y minus 6 inside. So y is equal to 0, or y is equal to 6. And y is 0, we've got x is negative 3 times 0, which is 0, plus 3, so 3. And when y is 6, negative 3 times 6 is negative 18, plus 3 is negative 15. So we've got our coordinates and we've got our gradient. So for the tangent, we know the gradient is 3. We know the coordinates. So it's m times x minus x1 equals y minus y1, or m times x minus x1 minus minus 15 equals y minus y1. And again, we could expand the brackets and put it in the form y equals mx plus c if we wanted to give our answer in that form. The points A, negative 2, 3, and B, 6, 7 lie on a circle C. So this time we've got a circle and we know 2 points on it. It says find an equation of the perpendicular bisector of the line segment AB. So this time the circle rule is that a chord, so any line joining 2 points on a circle, is called a chord, and the perpendicular bisector of the chord, so the line that's perpendicular that goes through the center of the chord, goes through the center of the circle. So we want the equation of the perpendicular bisector. So it bisects, that means it goes through the midpoint. So the midpoint of AB, so to find the midpoint, we can add up the x's and half them and add up the y's and half them. So negative 2 plus 6 over 2 and 3 plus 7 over 2 is the center. So that is at 2, 5. The midpoint, so this point here, the midpoint's at 2, 5. and we can find the gradient by finding the gradient of the chord and then flip a minus, negative reciprocal. So we'll have x1, y1, x2, y2. So the gradient of the chord is the change in the y's, which is 7 minus 3 over the change in the x's, 6 minus minus 2, and that is 4 over 8, or 1/2. So that means the gradient of the perpendicular bisector is perpendicular. It's a negative reciprocal, -2. So the equation of the perpendicular bisector is m times x minus x1 equals y minus y1. x1 and y1. And again, if we wanted it in a certain form, we could rearrange from there. Given the center of the circle has a y-coordinate of -1, find the equation of the circle. So we can find the center of the circle now by substituting in -1. So we know that this red line here, the perpendicular bisector, goes through the center. So if we substitute in its y-coordinate of -1, we can find its x-coordinate. So -2 times x minus 2 equals, so y is -1, -1 minus 5. So -2x plus 4 equals -6. Take 4 away from both sides. So -2x is -10. X must be 5. So the center is at 5, -1. The equation of a circle is in the form x minus a squared plus y minus b squared equals the radius squared. So we know the equation of the circle is x minus 5 squared plus y minus minus, so plus 1 squared, equals the radius squared. And we can find the radius squared by using either of the coordinates. So let's use 6, 7. So we know 6, 7 is on the circle. So if we use 6, 7, 6 minus 5 squared plus 7 plus 1 squared is the radius squared. 1 squared is 1. 8 squared is 64. So that's r squared is 65. So we know the equation of the circle is x minus 5 squared plus y plus 1 squared equals 65. One for you to try. Pause the video and give it a go. So again, we know 2 points on the circle. If we find the perpendicular bisector of those 2 points, it will go through the center of the circle. The perpendicular bisector of a chord goes through the center of the circle. So let's find the midpoint, halfway between -4 and 2. So add them up and half them, that's -1. Halfway between -3 and 9, add them up and half them, that's 3. So we know the midpoint is -1, 3. That's this point here. The gradient of the chord we can find by doing the change in y over the change in x. So that's 9 take away -3 over 2 take away -4. That's 12 over 6. That's 2. So that's the gradient of the chord. So the perpendicular gradient is the negative reciprocal minus a half. So we can write down the equation of the perpendicular bisector now. We know its gradient, we know a coordinate, so it's m times x minus x1 minus minus 1 equals y minus y1. Given the center of the circle has x coordinate of 3, find the equation of the circle. The center's got an x coordinate of 3. We know that this perpendicular bisector goes through the center. So if we substitute in 3 for x, so minus a half times 3 plus 1 equals y minus 3. 3 plus 1 is 4. Minus a half times 4 is negative 2. Add 3 to both sides. Y must be 1. So now the center of the circle is at 3, 1. So the equation of the circle is x minus 3 squared plus y minus 1 squared equals the radius squared. And then either of the points on the circle, so we can use 2, 9 or negative 4, negative 3. Substitute them in, so 2, 9, so 2 minus 3 squared plus 9 minus 1 squared is the radius squared. So that's 1 and 64. So r squared is 65 again. So we've got x minus 3 squared plus y minus 1 squared is equal to 65. And that is the equation of the circle.